so if we look at these things, work has to, I added these last two, standard entropy change and standard free energy. And so you get something like this. Calculate standard entropy change for the following process/reaction. That one's a process going from liquid to gas. And it's very simple. Liquid to gas. And it's just final minus initial. So you look in that grid and you find, looking for S in that grid, and S for liquid is units of joules. That's not SnCl4 gas. And it's always going to be S final minus S initial. Final is the gas, so 365.8 minus initial. It's positive. Right numbers here. Oh, there it is. 107.2. All of these are exactly like that. Yeah. I don't think it asks those questions on the test though. And then the other one is the delta G, which is called free energy. I have to finish adding these things, so let's do this one. Number 3.
Can you include the solids when you're calculating?
Yeah. This one didn't like the equilibrium stuff. You just find the thing in the list and use it. I've got the wrong value in there. I was rushing to do this. I've got the one for the solid, MnO2 solid. I needed the gas. This is what I was rushing through when y'all came in. The ones for the delta G, I guess, are just. Let's remove that. This one. But this is exactly the same thing. It's the delta. Final minus initial. So for this one, I've got these two. So this one's looking for delta G. You're going to have delta G equals delta G initial. But you've got two of these for your initial and one for the final, and you've got a 2 here. So I'm going to go minus. So my final minus initial. So my initial H2 gas, and I'm looking in the delta G column, H2 gas. Oh, that's right. These are elemental, so it's 0. So this is for H2, the R2. And then 2 times, I have to put this 2 here, and then I look up HBr gas, and that was negative 53.43. So all of that goes away. This is final. So 2 times 53 is 6.8. So negative 106.8. And it is negative because it is negative. These are exactly the same as the delta S. Let me go back and do another delta S. So I'll finish putting that information in there. It's not like I expect you to memorize all these numbers. And after this, we can just practice whatever you want to practice. Let's do this one. Just do this one. No, I didn't do this. 2H2 plus O2. This is H2 gas. O2 gas. X2. Value for H2 gas is O2 gas is 205.2. I've gone back to the entropy now. H2O liquid is 70. So I'm going to go it's not. S final minus S initial. There's the final, and there's a 2 there, so I'm going to go 2 times minus, I've got 2 times 130 here. 30.7. And add that to 205.2. Times 130.1. This is 260.2. .4, 26.6. Something's off somewhere. Just make sure you use the right value. I've got H2O gas here. Make sure you use the one for H2O liquid. Should I figure out what I did wrong?
You put 130.1 to 130.7.
I put 134.
130.1 instead of 130.7.
Okay, that probably do it. That's supposed to be the 7. But that's all there is to these. I've got to add those grids of data to the delta G ones. But that's all the thermodynamics I put in here. So today's a review day. What else do you want to review? Yeah. I can tell you that I didn't put Nernst on there, and I didn't put KSP from equilibrium concentration. But I put something from the rest of these. Some of the shorter ones, like redox, like which one of these is being reduced, I put a few on there. But other than that, all of these are represented. You've got a balance of basic, you've got a balance of acidic, redox reaction, a couple of cell schematics on there, cell potential calculation is on there. You want to go over those?
Yeah.
I'll give you these formulas. That's the way I remember it. Red cat minus an ox. Okay, so for question 1. What's being oxidized and what's being reduced?
SN is being reduced.
So what is the charge on SN here?
To
It becomes, and then the manganese becomes So this is being reduced, this is being oxidized. So we're looking for manganese neutral to manganese plus 2. You see down there, I just accidentally duplicated it there. And then you see the one for, let me point this out. You see SN2 plus and SN4 plus. Make sure you use the correct one. This is for SN2 plus. But you see in there, this is solid. And what you get is so this is, so don't look here, look here. SN is being reduced, so this is reduced. That happens at the cation, and this is the one being oxidized, the Mn. And then just plug in 1.185. Negative 1375. Make sure you keep track of all your negatives and positives. So what do we get here? In there. 048 is what's in there. 1, 2, 3, 4, 1, 2, 3, 4. Yeah. 1, 2, 3, 4. 4 significant figures. The 5 rounds the 7. And it does matter that it's positive. It means it's spontaneous. Makes sense. I'll give you this formula. But that's all there is, and I'll give you these. You just make sure you pick out the right one. You have to be able to tell what's being oxidized and what's being reduced so you know which one to plug in here. Is that good? All of them are like that. Anybody else? Solid. All right, what's being oxidized, what's being reduced? AU is being reduced, so you have AU here to AU solid. The charge on AU here know 3 is 1 negative, so 3 of those are here, so that makes that 3 plus. And then the iron is the other thing. You're going from Fe to this Fe. But do you see the charge?
Iron,
So what's the charge on Fe here?
2.
2. So there's 2 of these, and those are negative, so this is 2 plus. Here there's 3 of them, so this is Fe3 plus. So this is being reduced, and this is being oxidized. All right, and what you're given for information here, Au3 plus 3 electrons, is your Au. Given Fe 3 plus an electron, 2 plus. It's 2 electrons. So, just make sure, this is Fe3 plus to Fe2 plus. That's the one we want here. Even though we're going from 2 to 3, whether it's oxidized or reduced, it just depends on where we put it here. But we want the one that's got Fe2 and Fe3 in it, which is this one. This one is Fe2 plus 2 electrons to neutral Fe, and that's not what we're doing. There's no neutral Fe in there. And then the Au, we're going gold 3 plus down to neutral. This is gold 1 plus down to neutral. This is gold 3 plus down to neutral. So those are the 2 we want. We don't want those 2. So make sure you pick out the right one. You follow that? So I'll give you a few. We just got to make sure you pick out the right one. There's a huge list of all these in the appendix that we'll put. All right, so reduced is the Au. So there's our red cap, 1.498. Are all those positive? Yeah, they're all positive except for that one. All right, this is our ox, 771. Oxidized, Fe2, oxygen. $1.498 minus 0.771, and this equals it's positive, so that one's spontaneous. What was this one? It was 048, right? 1.048. You remember if it was positive or negative?
It's positive, it's spontaneous.
Anything else? I want to review. The session is for you. All right, these 2 are slightly different, so let's do one at each.
Is it true that if it's positive, it's always going to be spontaneous?
Yeah.
Okay.
The negative means non-spontaneous. Okay, to start like that, the ICE table is initial, change, and equilibrium. This tells us that initially somebody probably made a solution 0.25 molar of this. All of these are capital M. I'm just going to leave the units out. You also know that K, or in this case Kc, because it's concentration based. You have these. On top. And on the bottom you put these, except you're not going to use this because it's liquid. So you don't use the liquids and the solids, you use the aqueous and the gases. So there's K. So you're given K equals 1.8 times 10 to the negative 5. So there's that. If we start with this, I'm going to ignore this because it doesn't show up in anything. But, so if you start with that many moles of this, and then things change, the only way they're going to change is to go that way. I should have a double arrow. So this is negative x, or 1x, because there's sort of a 1 there. There's sort of a 1 there and sort of a 1 there. So 1x, and this is going to be plus x, and this one is going to be plus x. And these started at 0. Their initial was 0. So initial 0.25, initial 0, 0. And then the change is this one goes down and these two go up. And make sure you involve the coefficient here. So this is minus 1x plus 1x plus 1x. And then at equilibrium, so at equilibrium, this was 0.25 minus x. That's this one's concentration at equilibrium. Maybe I should do this. This one's concentration is 0 plus x. So I'm just going to put x. 0 plus x. And now you can plug in over here. 1.8 times 10 to the negative 5. Concentration x for this. Concentration x for this. Over 0.25 minus x. So now we're solving for x. In this case, it does end up being the concentration at equilibrium for these. But if there was a 2 here and a 3 here, then we'd have a 2 here and a 3 here. And once you solve for x, you still have to go back through this step to figure out what those are. And then the key here is it tells you the change in NH3 is small enough to be neglected. So this is such a tiny amount, it barely changes this value. So you can actually take this and hack it out. You end up with I'm going to go ahead and make this x squared. And you're down to solving this. Once you multiply both sides by 0.25, then you just take the square root and you got the x. You with me? Oh. Sorry, y'all. Tell me to put the camera on. So I took these values and plugged them into here, so we have this times this over this. This part can be neglected. I went ahead and turned this into x squared. So this is what you have. Multiply both sides by 0.25, and then take the square root, and you've got the x. Intermediate coefficients. There's one. We do this one. So this is number 3, I think. Okay, this one we're using KP, but everything's the same. So KP so you know that's true, and you're also told what KP is. KP is 2.2 times 10 to the negative 6. Ice. You're told somebody mixes it up. 0.824 atmospheres. 0.824. We're in atmospheres now, but it really doesn't change anything. We're in partial pressures instead of concentration. So someone puts that much of this in a sealed vessel, so that's the initial, and this starts at 0, this starts at 0. And then this starts to turn into these in that vessel. So the change is, there's a 2 here, so I'm going to go minus 2x, 2 here, so these are the plus, so plus 2x, and this one is just plus x. So there's a change. And at equilibrium, this one is equilibrium, this one is 2x. And at equilibrium, this one is x. It says, even though it's 2x, assume that the change in pressure of H2S is negligible. So we're going to get to ignore this in our final problem, which just simplifies it a lot. So we don't have to use the quadratic formula, it comes out much simpler. And we end up with 2.2 times 10 to the negative 6. This concentration, oh, I forgot something. I did forget something important. This 2 and this 2, do you remember what we do with those? They go here. Don't forget that. See what I mean? You remember that? Yeah, don't forget that. It's 2x with this. So that 2 shows up in 2 places in the final thing. You've got 2x here and the square here. This one is just x. And then that one is, I'm going to go ahead and drop this off. The change is negligible. That's what the last thing in parentheses says for the problem. So 0.824 and the squared as well. And now you're just going to solve. If you square that and then multiply both sides by that, times 0.824 squared equals, when we put these together, it's going to be 2x squared 2x squared is 4x squared. You follow that? You have to square everything inside the parentheses there. You see that? And then I still have to multiply it by one more x. So the numerator here ends up being 4x to the third. Then you divide both sides by 4. And once you get this numerical value, you use your calculator to find the cubed root. And that gives you x. So the concentration and equilibrium of this one is x. And the concentration of this one in equilibrium is 2 times whatever you found for x. You with me? Practice these. If they're not coming out right, let me know. Maybe I better go through this one just to be sure. I so want to do it in the spreadsheet. 2.2, no, 0.824 times 0.824. I'm doing this my old school way. I had a scientific calculator. Three of those, 8, 9, so this is a 9. So now I've got 2.2. So all I did so far is square that. Now I'm going to go 2.2 times 0.678. So now I've got two significant figures. I guess I have to go with 5 here. So that I just multiplied this by this and left this alone. 1.5 divided by 4 is so it's that. And now I need cubed root of that. And now that's what I've got for x. Is that in there? I ended up with 7.2 times 10 to the negative 3. You guys try this just to see if it's me. Solve this for x. Solve that for x. I might have forgotten that square, and I'll do it in the spreadsheet.
I don't think you're supposed to for the 3.824 on the bottom.
This?
Yeah.
There's not a 2 here? There's definitely a square there. Are you telling me that you've got the right answer by not squaring that?
I'm pretty sure.
Okay, then I made a mistake when I made the answer.
Wait, can you go to the question on,
There should be a 2 there for sure. That should be a square right there. Did you solve these and you did it without squaring that? And you got an answer?
yeah.
Okay, then it was my mistake when I made this. I need to fix it.
So the H2S is supposed to.
I think if we solve this with this square, that's the correct answer. And I need to change the answer. And I need to check all of them. So test Monday or Wednesday. Tomorrow review of the day. I better fix this now. Step value. Before. Zero point 824. This equals that. Squared. Equals that divided by 4. This to okay. Now I'm getting 1.2. Now I'm getting 1.2 times 10 to the negative 7. That's not gonna go.
Can you go back to the detail question again? You're saying to square the bottom part or not?
Yeah, that needs to be squared because it is. Not squared, minus 2x. So this does need to be squared. Now I'm getting the right answer. Did I just do it wrong?
I don't know. I'm doing it.
So maybe I did do it right. Well, I got 1.3. And that 10 to the negative 7 can't be right. This. That to the cube root.
Doing it your way, I got.
Squared. Huh?
Doing it your way, I got 7.20 times 10 to the negative 3. Squaring the bottom.
Did you square this? That's what I got for. Why do I do it wrong? Spreadsheet. 7 times L7. That's the numerator, it's that divided by 4. It's supposed to be a cube root. Yeah, 0.72 should be what it is. So that's what I did here. We should have done 7.2 times 10 to the negative 3. Did y'all go through these yet?
Yes.
And now you're having to learn it different? Is that what you got, 7.2?
7.20 times 10 to the negative 3.
Okay. I think it should be 2 figures though. Because of the 2.2 in KP. Sucks. No coefficients. No coefficients. So it's that 2 that messed me up. It's fixed now. Are you going to take this right after class? Yeah. Do you want to wait a while? Do you want to go back over things? I'll put one like that on the test. I have the test book because she's taking it today. But I think I want to do it without those coefficients. Yeah.
I have a question about class 6, like the first half.
Okay. Let's review now, and then you and I can talk about that. Okay. The one on the test doesn't have those coefficients, so it's not going to matter. But I had that wrong all that time. Let's do the KSP one. Do one of these. Molar solubility. Let's do number 1 here. So number 1 for the molar solubility KSP. so you're given that, you're told KSP equals the K here says this is solid, and these are aqueous. So that won't show up over here. So KSP equals okay, so all right, put that in, and this isn't going to show up over there, for it doesn't matter. So this is whatever. So whatever plus X, I'll say this is minus X, this is plus X, and this is plus 2X. So this is whatever minus X, but that's not going to show up anywhere. These were 0, so this one is X, this one is 2X. 0 plus 2X is 2X. 0 plus X is X. So now we have the values over here. We solve for X, and since that's this X, and then that's this X. So ultimately the molar solubility is the X that goes with this. But we're going to solve for X, and that's what X is. So X, this is X, this is 2X squared. So that's what we're solving. We just solve for X in this case. And we'll see if I did it right. We're solving 4x to the third. So I divide this by 4, and I get 0.35 times 10 to the negative 8. That's what I just got. Anybody else try to solve that? Drum roll. 1.5 times 10 to the negative. Well, I got it right. The one on the test, this one it ended up we go through this one, it'd be just identical. Because of where the coefficients are. But the one on the test is like this first one.
So you just neglect the solid from those?
Yeah, this is going back. You would remember this though. Whenever you did it some K value, whether it was KC or KP or KSP or whatever, you ignore when it's solid and you ignore when it's liquid. You only keep it if it's gas or aqueous. So we dropped that out. So what would usually be in the denominator here just wasn't there. bad that there's still mistakes in here, but that just means nobody's done this and asked me questions on it. It's been up there for weeks, so. This previous one that I had a problem on. So this one, KSP from equilibrium constant, that one's not on the test. And also I left off the Nernst equation off the test. I think pretty much everything else is on the test.
Can you go over balancing and half reactions?
Yeah. It's the same as the process you go through when you balance acidic and basic.
It just don't make sense to me.
Since I put balance acidic and basic on the test, I didn't bother to put this on there.
Oh, okay.
But let me see what you're.
I just balance them in different ways, so when you break them into that half reactions like that, it's no sense to me.
Okay, well, I'll just go ahead and say a question like that isn't on the test either. But if you guys are practicing things, even over the weekend, and you're getting wrong answers, please tell me. It could be that you're doing it wrong, or it could be that I should be honest.
I think on the KSP illustrations one, I think I did it the same way that you did for the answer key, so I got it right.
Yeah, I think that's what she did too. You didn't put the square in there, and of course,
Yeah.
you made the same mistake I made. As it stands, there's only, I think, 16 questions on the test. I mean, there's like one of each of these that don't say not on the test. And then I put a few of the redox questions on there, like what's being reduced and what's being oxidized. So I'll probably have to you only have to miss a few questions. And I mean, I could make repetitive questions on there, I just didn't want to. So I will grade it accordingly, on the curve. But do your best on it. I might do the makeup quizzes online, because I'm running out of time in this class and my other two classes for those. I promise all semester I'm going to do these makeup quizzes, and then I put them off, and now we're kind of running out of time. So I might be putting those online. We're supposed to do that Wednesday. We'll see. But if I put them online, that gives me room to put something up there for test 3. So we'll see what I do. But I got to work all weekend on this stuff, so. Yeah, I think 16 is what I had. That's 16. Any other questions? And if we're done, we're done. But oh, by the way, this is all my syllabus. If I'm not responding to email, like immediately, you can text me and go, look, I got a question, will you please answer it? I don't do anything on weekend. Well, actually, I'll be here all weekend working. But I'm not always looking at my emails, so. But I always notice when my phone goes off. So text me if you need to. I've never had a problem giving out my phone to students. So there you go. Any other questions? Yes. We are, final is, It's Monday, May 11th, 1 to 3:15, or you can come to the 3:30 to 4:45. You gotta come to one of them. You can't just like come any time between, because it's a time test. So if you come at 1 o'clock, you have till 3:15. If you come at 3:30, you have until 3:45. So I'll just do both of those sessions. Come to either one. I should post that on YouTube. Any other questions? You know what occurred to me is I should have been having her go through all my questions online to audit them. Could have made use of her. So here's your duties. You know what I mean? I have a task for you. I always just let the SIs function independently. I should have given them tasks. We should have had weekly meetings and all that stuff.
Sorry, Mark.
Yeah, well, I didn't ask, so why would you do it? I wouldn't. All right, y'all. Contact me if you got questions. Test Monday.